Hello everyone, this is Manohar Reddy, Department of Cybersecurity. Today I am going to discussing about indexing and hashing in DBMS. Indexing and hashing in DBMS. So indexing, what is meant by indexing? Generally we are going to have different types of files, different types of data in our systems as well as database. But what is the main importance about to indexing? To read the values or to search the values. So indexing is a mechanism that used to speed up the access to desired data. So it is a mechanism that used to speed up the accessing. So only for the speed up your accessing of the data, speed up your accessing of the desired data, we are going to be perform some operation. So what that operation is in indexing? So indexing is an operation. Indexing is an operation or mechanism that used to speed up the accessing of data, So how we are going to speed up the accessing process? So we are going to use the search key. So example, author catalog in library. So to want to search author catalog in library, we are going to have a different search keys. So search key is the main attribute. Search key is the main attribute to set of attributes used to look up records in file. So the search key searches each and every attributes in the records of the file. So it always looks up the records of the file. So it finds all the related information fast as it can do. So an index file consists of records called index entries. So an index file consists of records called index entries of the form. So generally we indicates that what this is the all index files, and this is the search key which is lookuping for the all records in a file, all records in a file. So index files are typically much smaller than the original file. Suppose a college contains roll numbers like 2012 like 270. 2012 to 270 records of a file contains. So for this all 2012 to 270, I want to access the 260 record. I want to access a 260 record without an indexing or without a search key. I want to check each and every record. So 201 I need to check, 202 I need to check, 203 I need to check, like the way up to 260 record I need to check. So that takes a lot of time to read that value. That takes a lot of time to see that value or search that value. So to avoid this latency or time taken process, we are going to use this indexing process. So and this indexing process, what they decided what 201 to 210 is one index. Similarly 210, 11 to 220 is index 2. Like the way they can differentiate with the indexes for all the records. So for all that indexes they created after that indexes, they can have the search key. With that search key, all the files will be looked up. So index files are typically much smaller than the original file. So there are two basic kinds of indices. Out there. One is what ordered indices. So which contains search keys are stored in sorted order. So search keys, we are already said that what 201 to 210 an index which contains search key. Similarly 211 to 220 is index 2 which contains search key. So for all that indices, search keys are stored in sorted order. Similarly, second one hash indices. So search keys are distributed uniformly across buckets using hash functions. using hash function. So search keys are distributed uniformly across buckets. So bucket wise they can distribute information for each and every search key. So they are distributed and using with the hash function. With the hash function, the search keys are distributed uniformly across buckets. So these two are important. These two plays an important role to find that each and every key. To find that each and every key. So index evaluation metrics. So what are the index evaluation metrics? That indicates that what is the main importance of using that indexes, what is the main motive of indexing, and what is the main uses of that indexing that uses. So access types is supported efficiently. First of all, access types are supported efficiently. So records with a specified value in the attribute, or records with an attribute value falling in a specified range of values. So they are taking each and every range of values with particular index. So for each and every index contains search key. So each and every search key searches for each and every record in the file. So that's why records with a specified value in the attribute, or record with an attribute value falling in a specified range of values, it indicates that one. So that is one evaluation metric, and another one is what? Access time. So it access with a less amount of time. So the search key takes a less amount of time to access the particular record, particular bucket. And insertion time also, to insert that value into that bucket or that records also, it takes a lot of less time. And the third one, deletion time also, to delete that value from the record, because of the search key is there, the deletion time is also taken very less amount of time. And the space overhead. So by distributing all these indices each and everywhere, so the space overheaded by that records also taken less amount of space is required for storing that all the values. So because of that indexing happen, there is a lot of space is reduced. So deletion time also reduced, insertion time also reduced, as well as access time also reduced, and access types also supported efficiently. So ordered indices. What ordered indices is? So in an ordered index that indicates that what the index contains all the records in an ordered way. So all the values in the record in ordered way. So index entries are stored or sorted on the search key value. So on basis of search key value, the values are sorted. So values are sorted, not like 207, 209, 203, 202, not like this. These are all sorted in 201, 202, 203, 206, like the way. So the all index entries are stored, sorted on the search key value. So example, author catalog in library. So that is nothing but what? Ordered index. And the primary index. So primary index, in a sequentially ordered file, the index whose search key specifies the sequential order of the file. So whose search key specifies the sequential order of the file. So it also called as clustering index. To avoid confusion with the primary key. So the search key of primary key index is usually, but not necessarily, the primary key. So the search key of the primary index is usually, but not necessarily, the primary key. So primary index contains the sequential of order file, and whose search key specifies the sequential order of the file. So which is the direction of the file, that is primary index. And the secondary index. So an index whose search key specifies an order different from the sequential order of the file. So the primary index shows that what? Sequential order of the file, but secondary index shows that what? Different from the sequential order of the file. and is also called as what? Non-clustering index. Also called as what? Non-clustering index. So all these records are inserted. All these records are inserted into the index file with sorted order or unsorted order. So all the sorted order will be taken as a primary index. All these sorted order are taken as a primary index, and all these unsorted order taken as a secondary index. Secondary index. So this is also called as non-clustering index, and this is called as clustering index. Clustering index. So these are the ordered indexes. Order indices. So ordered index, the primary index and the secondary index. And the index sequential file. Index sequential file. So ordered sequential file with a primary index. So the sorted order contains what? An primary index. So order sequential file with the primary index is called as what? Index sequential file. Index sequential file. And the second one, dense index files. So dense index. The dense index record appears for every search key value in the file. So index records appears for every search key value in the file. So example, index on ID attribute of instructor relation. So this is all about instructor relation or instructor table. Instructor relation or instructor table, which contains index IDs, which contains ID, instructor name, instructor subject, and instructor salary. So this is what? Instructor ID, instructor name, instructor subject, and instructor salary. So here the ID will be taken as an index. ID will be taken as an index. So based on this index, we are going to find the values of find the values of instructor name, instructor subject, and instructor salary. So based on that, so this is the index. This is the index value. This is the index value, which shows that what index 10101 index contains the information. So what it contains actually? It contains the instructor name as Srinivasan. It contains the instructor subject, computer science engineering, and it contains the instructor salary 65,000. So like the way each and every records will be taken as an index. So 10101 is an index for this record, 12121. So here ID will be acting as an index. ID will be acting as an index. So based on that IDs only, we are going to retrieve the information of all these. So 101 indicates that what? It towards the next ID. Again the next ID indicates that what? Next ID. So next ID, like the way till last IDs. So this is all called what? Dense ID. So index record appears so for every search key value in the file. For every search key value in the file. So each and every record I will forward it to the next record. So dense index on department name. So if we are taking a dense index on department name with the instructor file sorted on department name. So if the department names are sorted, in the sorted order, so B for biology, C for computer science, E for electrical engineering, and F for finance, and H for history, music, and physics. So these are all the department names. Which shows that what? Which shows that instructor files. So biology department name indicates that what? The instructor ID along with that instructor information. Similarly, computer science engineering, computer science file indicates that what? 10101 as a instructor ID, instructor name, instructor subject, and salary. So that shows that what? Next instructor ID. So this is all about dense index on department name. So that indexes indicates that what? Next value of the index is that shows. So here The finance index also showing that what next index, and history also showing that what next index, music also showing that what next index, and physics also showing that what next index. So for all the every dense index name on department name which is related to the all department values, which are all instructor values. So instructor number, instructor ID, instructor name, instructor subject, and instructor salary. And next, sparse index files. So sparse index. So what it contains actually? It contains index records for only some search key values. For only some search key values, not for all search key values. It contains index records for only some search key values. So it applicable when records are sequentially ordered on search key. So it occurred applicable where only some records are sequentially ordered. Some records are sequentially ordered on search key. So here to locate a record with search key value k, we have to find index record with the largest search key value less than k. Find index record with the largest search key value less than k. So search file sequentially starting at the record to which the index record points. Which record points. So what it points? So 10101. So we are taking index records only for 3. So 10101, 32343 and 76766. So only these three indexes are finding the records based on their search keys. So only these three indexes are finding the records on their value basis. So 10101 indicates that what? 10101 as an instructor ID information and instructor name, instructor codes as well as instructor salary. So that does not shows all the information. That shows for that pointing towards the next one pointing towards the next one pointing towards the next one. Similarly, next one, like that. All the informations, all the records that will be showing for the last one. But only the sparse index shows that what it takes some sort of keys, only some search key values only it takes. So based on that only we are going to find the information, find the records of the information. So finding the information about that only for particular records. So compared to dense indices. So what is the difference between both the dense indices and sparse indices? So it takes less space and less maintenance overhead for insertions and deletion operations. And generally it is slower than a dense index for locating records. So generally it is slower than dense index. For dense index it is slower than it is very slower than dense index for locating records. And a good trade-off also. So sparse index with an index entry for every block in file. So corresponding to least search key value in the block. So sparse index with an index entry for every block in a file. So corresponding to least search key value in the block. So which contains data blocks 0, data blocks 1. So it shows that what sparse index of the values, data block 0, so which is an index which contains the data, and here which contains the for the second index, this is the first index. So first index contains data block 0, for second index data block 1. So it maintains less amount of wastage, less amount of space it takes. So this is all about to comparing of dense indices and sparse indices. So here the secondary indices examples. So what is meant by secondary indices? So here all the records, these are all the salaries, and this is all the IDs. So each and every index pointing towards each and every one. So here this is we are taking as a search key values of the salaries. So salaries are the search key values. So with this 40,000 search key, we are going to find the values. We are going to find the value. Whoever taking the salaries of 40,000, only it pointing towards, and whoever taking the 60,000 value as a salary will be pointing towards. And this will be acting as a primary, and this will be acting as a secondary. So here the secondary indices are indicating that what to find the information about each and every instructor information. So here instead of using primary indices, we are using secondary indices. So index record points to a bucket that contains pointers to all the actual records with that particular search key value. With that particular search key values. So secondary indices have to be dense indices. Secondary indices also have to be dense indices. So this is about secondary indices. So here once again we revise the topics which we discussed in this session. So here we are discussing about the indexing and the hashing. So what is meant by indexing and what is meant by search key, what is the value of index file contents, and what is the value of index entries. So all this we are going to discuss. So we are discussing about indexing is what. Indexing is nothing but it is a mechanism, or it is a part to speed up the accessing of the file, to speed up the accessing of the desired data. So example, author catalog in the library. So to do that all the processes, we are going to use that word search key. We are going to use some search key. So what is the use of search key? It checks each and every record in the file. It checks each and every record in the file. So set of attributes are used to look up records in a file. And an index file consists of what? Records. Index file consists of what? Records. So all the records will be index entries. All the records will be contained as index entries. So two basic kinds of indices are there. One is what? Ordered indices. One is what? Ordered indices. And the second one is what? Hash indices. Second one is what? Hash indices. So on what basis we are going to use these index mechanisms? So on basis of to improve the access time, to take the access time, to reduce the insertion time, to reduce the access time, reduce the insertion time, reduce the deletion time, reduce the space overheaded taken by the device or taken by the memory. So access type supported efficiently here: records with a specified value in the attribute, and records with an attribute value falling in a specified range of values. So ordered indices. So what is meant by ordered index? So index entries are sorted in the search key value. So index entries, what are the values you are going to be stored, will be stored in the form of in the entry of sorted order. So example, author catalog in library. And second one, primary index, secondary index. So index file. So primary index is what? The sequentially ordered file. The index whose search key specifies the sequential order of the file. So whose search key specifies the sequential order of the file. It is also called as what? Clustering index. So sequential index, primary index is also called as what? Clustering index. And the secondary index is also called as what? Non-clustering index. Non-clustering index. So it is not going to be clustered, but primary index is to be clustered. So it is clustered based on the index that the index entries that have. And the index sequential file. So ordered sequential file with primary index. So ordered sequential file with primary index. Dense index files. So here dense index files which contains index records appears for every search key value in the file. So index, these are all the index records: instructor salary, instructor ID, instructor name, instructor subject, instructor salary. All these are index values. So here index record appears for every search key value in the file. So this will be acting as a search key. This is all about to index records. So index records appears for every search key value in the file. So for each and every values, a search key is there. So example, we are taking what index on ID attribute. So index on ID attribute will be the search key. ID will be the search key for this all instructor relation. So on basis of this search key, so on basis of this 10101, you are going to find the information of 10101 instructor name, instructor salary, instructor's course. And similarly, second search key, second index record, third index record, fourth index record, fifth index record, sixth index record. Like the way all each and every index records will be find the information based on the search keys, So here the index ID, here instructor ID will be taking as an index ID, and the dense indexes. So here also we are taking what department name with the instructor file sorted on department name. So here department name will be the acting as a department name will be acting as an index ID. So department name will be the acting as an index ID. So based on this index ID, so how many of the teaching that biology, how many of are teaching computer science, that will be pointed to the next instructor information. That will be pointed to the next instructor information. So once the department names are acting as a search key values, so in the previous slides, search keys are IDs, search keys are instructor IDs. But in this case, search keys are what? Department names. Department names are search keys. So based on these search keys, we are going to finding the instructor information. So who teaches biology will be display the information. Who teaches the computer science will be displays the information. Who teaches the electrical engineering will be displays the information. Like the way all these primary indexes information will be displays. Next is sparse index files. So sparse index files are nothing but it maintains only some certain sort of search key values, not using all search key values for index records. Only some search key values will be taken as an search key values, index values. So only some sort of search key values will be taken as an index values, so that all these search key values, some search key values are going to be displays the information. Remaining all are pointed to the next one. But not to show. And only some sort of search key values applicable when records are sequentially ordered on search key, and remaining all are not displays. So to locate a record with search key value k, we are going to find index record with the largest search key value and search file sequentially starting at the record to which index record points. So only some sort of search key values has to be taken. Based on that, only the information, the index records information will be displays. So here compared to dense indices, so compared to sparse indices and dense indices. So what it takes? So it takes what? Less space and less maintenance overheaded for the insertions and deletions. Generally slower than dense indices for the locating records. So this is the index records. Index records are pointing towards data blocks. So here this is what index block, and this is what data block. So each and every indexes are stored in index blocks. So this will be acting as a search key. So each and every search key searches for the information about this key. So this is the search keys, this is the index blocks, and these are the data blocks. So index block contains what? Indexes. Data block contains what? Data. Data blocks contain what? Data. So here the first index will pointing to the data block 0 and the second index will be pointing to the data block 1. So because of that, comparing the trade-off indices, it takes good trade-off. So sparse index with an index entry for every block in file corresponding to least search key value in the block. Least search key value in the block. And the secondary indexes example. So instead of using these all primary indexes, it uses the secondary indices, mediator indices. So that indicates that indices is called as what? Secondary indices. Secondary indices. So secondary index on salary field of instructor. So this is the secondary indices. This is the primary and this is the secondary. So salary field will be the secondary field. So based on this secondary field, it identifies the primary one. So based on this salary, the record will be displayed. So maintaining that first and second information, maintaining that first and second index information, it displays the information which is related to the index, So index record points to a bucket that contains pointers. So this is all we can call it as buckets. So based on that buckets that contains pointers to all the actual records and with what particular search key values. And secondary indices have to be dense indices. So to reduce the access time, to reduce the file access time or record access time, we are going to use this concept called indexes or indexing, which maintains search key values, to find the information, So indexing is a mechanism to speed up the process to access the file. So this is all about to indexing mechanism and primary and secondary indices. So this is all about to indexing and hashing. So that's all about to indexing and hashing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.